So welcome again. Today we will touch touch upon the topic patterns patterns in whole numbers. Okay, there are certain patterns in the whole numbers that make the calculation easier for the students. Okay, and this is the same chapter uh, chapter number 2, whole numbers. Okay, so this is the same chapter that we are talking about here. So the same chapter we will talk about some patterns, and we'll start with the pattern from 1 and 2 and 3 and 4 and 5. Okay, and with these patterns, first the pattern that we are talking about over here is the dot patterns. Okay, so dot patterns we are talking about means dotted dots and dots and dots. So the pattern that can be made by the dot, first is the line. A line can be made if we represent a number by the dots. Okay, what second we can do, we can make a triangle. Third, we can make a square, and fourth, we can make a rectangle. Okay, you just wait and you will understand what I'm talking about. Okay, so a line means simple line. You are putting like this is a line. This is the pattern that can be made by any number. Okay, by any number you can make this kind of pattern except 0 and 1. Okay, and rectangle you can make like this, and square also like this and this. Okay, and the triangle can be made like this and this and this. So this is a triangle. Okay, so these kind of patterns can be made from the whole numbers. Okay, so we'll explain this by taking some examples. We are explaining this kind of pattern and all the patterns that we will study here today, so that is for the ease of making the calculation easier. That's all. Okay, so 2 can be represented. 2, how will represent it? By making two dots. So what is this? This is a line. Okay, number 3, how can we represent? We can represent by marking 3 dots, and this is also a line. But 3 can be represented by triangle also, like this and this. So this is a triangle. Okay, what the point? Similarly, let's take number 4. Okay, number 4 can be represented as line also, and it can be represented as a square also, and it can be represented as a rectangle also. Okay, so this is a square and this is a rectangle. Okay, fine. Similarly, other numbers can be represented like this. Okay, let's take another example of let's take 5. Okay, let's take 5. Not 5. 5 may not be okay, because with 5 we can make only line. Okay, let's take 5 only. So 5, with 5 we can make lines. Okay, so line is there. We cannot make a square from this. We cannot make a rectangle from this. We cannot make a triangle also from this. Okay, so we'll leave it. Let's take 6. So 6 line can be made by any whole number. Okay, so this is a line, and we can make a rectangle also from this. This is a rectangle. Okay, so this kind of patterns can be made. Okay, let's take another number. There are many other numbers are there we can make we can make a patterns. Okay, so after some time we'll explain you why we are making these kind of patterns. Okay, for example, 9 is there. So with the 9 you can make a rectangle like this. Not, this is a square. Basically this is a square. You can make rectangle also from this. So this kind of patterns can be made by any whole numbers. Okay, so we'll represent will represent some, suppose 12 is there, so 12 is there, so 12 we can represent like this. We make a 4 and 4 in a line, and then 3 rows. Okay, so we can write this as rows are 3, and how many dots are there in a row? There are 4. So we can write 12 as 3 cross 4. Okay, and we can also write this as by making 6 dots in a. Okay, so what we can write this? We can write 2 cross 6 because there are two lines and each line having 6. So what we are trying to tell you, that 3 by 4 can be written like this also. Okay, okay, got the point? So this can be interchangeably used. Okay, so there are few small questions also. This first question regarding this dotted means representing by dot is, which number can be shown only by a line? Okay, which number can be shown only by line? Okay, so what we have seen just now is 2. Okay, 2 can only be represented by a line. Okay, it cannot make a square or triangle or rectangle, whatever. Okay, so this is the question. Okay, this is the answer. Second question is there. Which can be shown as squares? Okay, which can be which means which whole number can be shown as squares. Okay, so we'll take example of 4. Okay, so 4 is there, which can be made as, there are other numbers also. This 9 is there, so 9 can also be represented as a square. So 4 we will write 4. Okay, which can be shown as rectangle? So 4 can be shown as rectangle also. Okay, so we'll can represent like this. So this is a rectangle. Okay, 6 can be means shown as rectangle. Okay, so this is like that. Okay, okay, right. Now we'll proceed to other patterns, and we'll observe patterns, and we will try to learn what means what can be get from those. Okay, so in the book itself, it is written like 117 plus 9. Okay, so this kind of pattern, if it is there, so what we can write here, if that is 9 is there, 9 can be written as 10 minus 1. Okay, so what we can write here, 117 plus 10 minus 1. Okay, so any kind of operation over 10 or number that is having means 10 or 100 or 1000, it is easier. Okay, so we can add these two, and it will be 127 and subtract 1, and we'll get 126. Okay, so adding, subtracting, multiplying by the number 10 or 100 or 1000, it is a lot easier. So what another example is there? Yeah, that is 117 minus 9. Here we have done a plus, and here it is 9. So similarly, you can write this as 117 minus 9. It is here. Okay, so now minus 9 we can write as minus 10 plus 1. Okay, we want to introduce 10 here. Okay, this is the means beauty. So we subtract this, you will get 107. We'll added this, subtracted this plus 1, or what we'll get here, 108. Okay, similarly, if we increase this means number 9 to 99. Okay, let's take another number in place of this. Let's take 126. Okay, plus 99, and we can write 99 as 100 minus 1. Okay, so what will be this? 126 plus 100 minus 1. Okay, so solving this is very easy. So combine this, it will be 226, sorry, minus 1, and now it will be 225. Okay, fine. Now instead of taking plus here, we'll take minus. So 126 minus 99. Okay, it will be written, it can be written as 100 minus 1. Okay, if we expand it or this will be minus 100 and this minus will become plus. Okay, so plus 1, so it will be 26 plus 1, it will be 27. Okay, so what we are trying to tell here, that if there is a number for subtraction or addition 999 and 999, okay, so you need not sum or add these numbers, but instead you can write these numbers as 10 minus 1, this one as 100 minus 1, and this one as 1000 minus 1. Okay, so if you do it like this, then the means calculation will be quite faster and easier. Okay, so similarly, not only in the means addition and subtraction, in the same way you will find in the multiplication also. Okay, let's take some example of the multiplication. Let's take 65 multiplied by 9. Okay, so what we can write here for multiplication, let's see, multiplication. So basically these are the patterns that we have to observe and find out how can we exploit this the means situation of these means patterns to make our calculation easier. Okay, so 9 can be written as 10 minus 1. So this can be written as 65 multiplied by 10 minus 1. Okay, so and calculating this is quite easier. So 65 multiplied by 10 minus 65 multiplied by 1. Okay, it's like that. So it is 650, okay, minus 65. Okay, now it is 580. What the point? So in this way, if you multiply or sum any number that is yeah, means having 9 as a multiplier or 99 as a multiplier, it is quite easy. Okay, so till now we have means seen that it is easy to add some subtract that is having multiplication or sum as 9, 99, 9,999. But instead you are, if you are having means multiplier as 5, okay, multiplier as 5, so this also becomes easier, or 50 is there, or 500 is there. Okay, so you can utilize this kind of means patterns to make your calculation easier. We'll take some examples for this also. Let's take a example 75 multiplied by 5. Okay, so instead of multiplying 5 to these numbers, we can write this as 75 multiplied by 10 upon 2. Okay, so this will be 750 upon 2. Actually we should have taken an even number here for better understanding, but anyway this is the process. And let's take another number that is even also. So let's take 66 multiplied by 5. Okay, so we can write this as 66 multiplied by 10 upon 2. Okay, so if you divide 2 to 66, you will get 33. So you will get answer as 330. Okay, you multiply 10 to this one. Okay, multiplying by 10 to any number is very easy. You just need to add 0. Okay, okay. Now let's take another number, like means you can take numbers like let's take 45 is there, and you are multiplying by 25. Okay, so 25, what you can write, just a minute, let's take another example, it will be not that easy. So let's say 36, and you are multiplying by 25. So 25 can be written as 100 divided by 4. Okay, we can write it easily. So this can be written as 36 multiplied by 100 upon 4, and 4 9 ja 36, and 9 then multiplied by 100, it is 900. So this way the calculation is quite easy instead of multiplying 25 to 36. Okay, I think you are getting my point, what I am trying to tell you. Let's take another example, little means of higher grade. So let's take 124 multiplied by 25. Okay, this much long number is there. So if you are going to multiply by 25 to 125, it will take a lot of time. But if you know this pattern, then you can write like this: 100 upon 4. Okay, and you just need to divide 4 to 124. Okay, so 4 to 124, if you divide 4, if you divide 124 to 4, you'll get 3 and 1. Okay, so simple answer is 3100. Okay, you multiply this one by adding two zeros. Okay, fine. So this is the process through which you can exploit the things and make your calculation easier. So other numbers also you can take, like you can take another number which are having 5 at the unit digit. So those numbers also can be considered like this only. Okay, now we'll go to exercise 2.3, and we'll solve exercise, sorry, exercise 2.3, and we'll solve all the questions. Okay, I think should we take another means session for this? Actually, it will be better if we take another session, because the things will be separated on the video also. So I think it will be better to take another session for this, and so that everyone can have a separate means session for exercise 2.2. So let's finish this theory part, and in the next video we'll take up the exercise 2.3 of this chapter. So you will be able to understand. I think this much it is very clear to you, and you have understood fully. So exercise 2.3 we are taking another session in another video. Okay, so thank you very much. We'll meet again.